Welcome to today's ArXiv CS Digest for March 26, 2026. We received 696 new computer science papers today across 54 subfields. Let's dive into the top picks. Trend 1 of 5. LLM reasoning, training, and decoding. Advancing large language models' reasoning, optimizing their training, and improving decoding efficiency define this research trend. This cluster covers 147 papers. Representative work includes training the knowledge base through evidence distillation and write-back enrichment, back to basics, revisiting ASR in the age of voice agents, and S2D2, fast decoding for diffusion LLMs via training-free self-speculation. Trend 2 of 5. Generative models for embodied control. Generative models synthesize data, behaviors, and world understanding, enabling embodied agents to learn and control complex tasks. This cluster covers 122 papers. Representative work includes less Gaussians, texture more, 4K feed-forward textured splatting, Vega, learning to drive with natural language instructions, and Drive My Way, preference alignment of vision-language action model for personalized driving. Trend 3 of 5. Advanced visual content generation. These papers advance AI models for generating, understanding, and manipulating diverse, complex visual content, from automated design to multi-shot video. This cluster covers 160 papers. Representative work includes ShotStream, streaming multi-shot video generation for interactive storytelling, MUF, unlocking the multi-scale potential of vision foundation models, and RefAlign, representation alignment for reference to video generation. Trend 4 of 5. Foundational computational and AI methods. This trend advances foundational computational and AI methods, focusing on efficiency, trustworthiness, and novel techniques for complex problem-solving. This cluster covers 165 papers. Representative work includes quantum eigenvalue processing, sensitivity and Hamming graphs, and neural network inversion of machine learning pipelines. Trend 5 of 5. AI agents, applications, and theory. This trend explores AI agents, their diverse applications, and the foundational theories driving the advancement of artificial intelligence. This cluster covers 102 papers. Representative work includes How Good Was My Shot?, quantifying player skill level in table tennis, natural language agent harnesses, and agent factories for high-level synthesis. How far can general-purpose coding agents go in hardware optimization? Up next, our first paper out of 5. Labeled compression schemes for concept classes of finite functions by Benchong Li. Let's break down its key contributions. This paper introduces a novel labeled sample compression scheme specifically designed for concept classes of finite functions. Its key innovation is achieving a compression size exactly equal to the VC dimension D, thereby resolving the long-standing sample compression conjecture. Up next, our second paper out of 5, MIRAGE. The Illusion of Visual Understanding by Mohammed Asadi and Ewan Ashley from Stanford University. Let's break down its key contributions. The paper identifies MIRAGE reasoning, where frontier models generate detailed, pathology-biased descriptions and reasoning traces for non-existent images. This exposes a fundamental vulnerability in visual language understanding. It demonstrates that models achieve surprisingly high scores on multimodal benchmarks, even medical ones, without any image input. This questions the utility and design of current evaluation methods. The study shows that explicitly instructing models to guess without images significantly reduces performance compared to the implicit MIRAGE regime. This highlights the influence of prompting on model behavior. The paper introduces BClean, a principled solution designed for fair, vision-grounded evaluation of multimodal AI systems. This aims to eliminate textual cues that enable non-visual inference. Up next, our third paper out of 5, On the Foundations of Trustworthy Artificial Intelligence by T.J. Dunham from ARC. Let's break down its key contributions. This foundational contribution formalizes the determinism thesis, stating platform deterministic inference is necessary and sufficient for trustworthy AI. It introduces trust entropy to quantitatively link non-determinism with verification failure probability, establishing a core theoretical framework. This contribution proves the determinism verification collapse, showing that verifying deterministic computation requires only O1 hash comparison. Conversely, non-deterministic computation verification becomes an intractable membership problem, highlighting the critical need for determinism. To overcome the non-determinism of IEEE 754 floating-point arithmetic, the paper constructs the ARC engine. This pure integer inference engine ensures bitwise, identical output across diverse hardware architectures like ARM and x86, resolving a fundamental barrier. This contribution demonstrates multi-node deterministic inference using DAG consensus, where geographically distributed nodes produce identical outputs. These outputs are verified through on-chain attestation transactions, establishing trust and reproducibility in distributed AI environments. Up next, our fourth paper out of 5, Decidable by Construction, Design Time Verification for Trustworthy AI by Houston Haynes from Speakeasy Technologies, Asheville, North Carolina. Let's break down its key contributions. This secure by construction architecture sandboxes unverified AI controllers, ensuring overall system safety and security simultaneously. It eliminates the need for formal verification of the complex AI components themselves, simplifying deployment in critical systems. A supervisor component leverages augmented control barrier functions to check AI controller inputs. It decides whether to accept these inputs based on desired invariance and opacity properties, acting as a crucial safety and security gate. A parallel safety security advisor provides fallback control inputs when the AI controller's outputs are rejected. This ensures continuous safe and secure operation of the cyber-physical system, even when the primary AI controller fails its checks. Up next, our fifth paper out of 5, Enabling ab initio geometry optimization of strongly correlated systems with transferable deep quantum Monte Carlo by P. B. Zab O. and F. No. E. from FU Berlin, Department of Mathematics and Computer Science. Let's break down its key contributions. The paper introduces a transferable deep learning variational Monte Carlo (VMC) approach, continuously sampling nuclear configurations during electronic wave function optimization. This yields highly accurate, zero-shot transferable electronic descriptions across various molecular geometries. It integrates a cost-effective method for estimating VMC energies, forces, and Hessians. This enables efficient and accurate evaluation of the potential energy surface at sample geometries, crucial for subsequent molecular configuration space characterization. The method employs Gaussian process regression to aggregate noisy VMC energy and force data from sparsely sampled geometries. This constructs local approximations of the potential energy surface, facilitating exploration tasks like geometry optimization and transition state searches.